to today's webinar. I am Chaganti Srinivas, Deputy Director General in NTIPRIT, and I am going to be the host for today's webinar. Senior officers and friends from within the department across the industry, we at NTIPRIT are extremely privileged to have Secretary Telecom for accepting our invitation to inaugurate the webinar. Thank you, sir. We are also thankful to Director General Telecom for joining the webinar. Thank you, sir. Well, the topic of today's webinar is artificial intelligence applications in telecom sector. In fact, there was a reference from Secretary Telecom, sir, some time back to conduct a workshop or a webinar on the topic, looking at the importance and relevance of it. Well, India has taken a unique approach to its national AI strategy by focusing on how India can leverage AI not only for economic growth but also for social inclusion. Niti Aayog, the government think tank that conceptualized and articulated the strategy, calls this approach AI for all. Niti Aayog published India's strategy document on AI in June 2018. Niti Aayog basically focused on 5 major sectors, that is healthcare, agriculture, education, smart cities, infrastructure, smart mobility, and transportation. Later on, MIT has also come out with a policy framework on AI, and in DOT, a committee was constituted for standardization in AI technologies and to come out with an Indian stack which is underway. Senior officers and friends, I will not dwell much into this topic subject as there are expert speakers to do that. Today's webinar has mainly 3 components, that is inaugural session, then we have the technical session, and lastly we have the question and answer session. I hope the webinar will be useful to all the participants, and all the participants will be immensely benefited from the webinar. And now for the inaugural session, we are delighted and privileged to have Shri K. Rajaraman sir, Secretary Telecom and Chairman DCC. We are also delighted to have Shri UK Srivastava sir, Director General and Head NTIPRIT. Subsequently, we'll have the technical session. For the technical session, we have roped in eminent speakers from across the industry who have vast experience and have worked in this field. We have Mr. Jayaram Beladakere from Ericsson, Bengaluru, Mrs. Meena Arunachalam from Intel, US, Mr. Anish Mishra from Reliance Jio, Mumbai, Mr. Saurabh Basu from CDoT, Delhi, Mr. Srinath Reddy from COIGN, which is a startup company from Hyderabad. Friends, senior officers and friends, NTIPRIT is overwhelmed by the response we have received to this webinar. I am grateful to all the participants. Such keen interest and overwhelming response shown by the participants helps we at NTIPRIT. It encourages us to come out with more such programs in the future. I'll not take much time. Now we will commence with the first session, that is the inaugural session, with the welcome address from Shri UK Srivastava sir. Just a small brief introduction of sir. Srivastava sir is a very senior ITS officer of 1983 batch, having over 3.5 decades of rich experience in the field of telecommunications. He has earlier worked in TRAI at a very senior position and is a familiar face in the telecom industry. He has also working exposure in ITU. He is presently working as Director General and Head NTIPRIT and has been the driving force behind this webinar. Over to you, Srivastava sir.
Thank you very much, Srinath. Ladies and gentlemen, good morning. I extend a very warm welcome to our Secretary Telecom and Chairman DCC, Shri K. Rajaraman sir, who has kindly spared his time to inaugurate this webinar. We are conducting this webinar, as Mr. Srinivas has alluded, at the behest of our Secretary. He takes great interest in technologies and their applications. Welcome, sir. Your encouragement and participation in this webinar will go a long way. I also extend very warm welcome to Sri A.K. Tiwari and Sri A.K. Mittal, members of DCC, and Sri Nizamul Haq, Director General Telecom, to this event. Ladies and gentlemen, we are very pleased to have eminent speakers today. Srinath has already introduced them. Mr. Jayaram Beladakere, he has already participated in one of our webinars earlier. Ms. Meena Arunachalam, she's joining directly from West Coast, USA. She represents Intel. Then we have our own speakers from CDoT, Geo, and so on. So welcome to all the eminent speakers also. We are thankful for your participation in this webinar. I'll also welcome other invited guests, including officers from DOT headquarters, TRAI, TEC, CDoT, Telecom Industry, Academia, and my colleagues from NTIPRIT. Welcome all of you. As you all know, the artificial intelligence is made up of three principal branches: big data, automation, and artificial intelligence. The big data gathers large data sets on which analytics are applied to gain insight and enhance decision making. Automation is where machines follow pre-programmed rules to run processes and generally used for repetitive tasks. The final area is most advanced artificial intelligence, where machines perform cognitive functions similar to those attributed to humans. Mobile data analytics and artificial intelligence are emerging as powerful forces transforming business and society, and the potential of these technologies to unlock life-changing benefits is only beginning to be seen. When grounded in ethical principles that protect privacy, these solutions can truly change the world for the better. PwC estimates that over the next 5 years, 150 million people could be positively impacted by mobile big data and AI solutions, equating to 3% of world population. I'm sure quite a significant proportion of this will be coming to India, our own country. There are many applications of AI in telecom services, but I'm more fascinated by the use cases in the telecom network optimization. This mobile communication, as it enters the 5G era, new technologies, features, services, and applications emerge one after another. The traditional telecom network operation and management mode do not meet the increasing requirements of network evolution, service development, user experience, and operation analytics. In addition, the traditional mode is not able to effectively improve the network operation efficiency and control the operation costs. The industry has realized that the 5G era requires a highly intelligent automated network followed by intelligent autonomous network. Intelligent autonomy is an important enabler for innovative business models to mobile communications and will become the essential element of mobile communication networks in post-5G era too. The introduction of AI into mobile networks will be an inevitable requirement for network design, deployment, operation, assurance, and optimization in 5G and post-5G eras. To implement intelligent autonomous networks, the entire industry needs to have a unified understanding of intelligent autonomous networks, clearly define the concepts of intelligent autonomous networks, specify each development phase and objective of intelligent autonomous networks, and jointly incubate intelligent autonomous network use cases. The convergence of AI and communications networks will inject new technological vitality into communication networks and open unprecedented possibilities, and AI in networks is the key to success. Today's webinar will delve upon this and many other related issues for the benefit of telecom issues. I once again welcome all of you to this webinar and hope this benefits you all. Thank you very much for your presence today. Thank you.
Thank you, sir. Thank you so much for the welcome address and also for your wonderful thoughts. You have indeed set the tone for the webinar. Now I take the privilege to invite our head of DOT family, Sri Rajaraman Sir, Secretary Telecom and Chairman DCC. Just a brief introduction of Sir. Rajaraman Sir is a 1989 batch Indian Administrative Service Officer. So before joining the present position, he was holding a key position as Additional Secretary in Department of Economic Affairs. So he has worked towards fostering economic relations worldwide and particularly G20 and BRICS nations. He holds a bachelor's degree in engineering and master's degree in financial management. So now I request Secretary Sir to share his thoughts and also declare the webinar open. Over to you, sir.
So, a very good morning to all of you. I first of all wish to thank Mr. Srivastava, Director General of NTIPRIT, in enabling this forward-looking workshop, which attempts to share the experiences worldwide and within India on the use of artificial intelligence for enabling various opportunities in the telecom sector. So, the Director General has very rightly said in the beginning itself that it enables a lot of use cases, and it has got a potential to enhance a number of things. For instance, things like the productivity, reducing the costs, enabling better experience, enhancing security. So there are several objectives of use of artificial intelligence, machine learning, deep learning, etc. in telecom networks. So there are many objectives, and I think we may be able to identify more and more applications based on the objectives that are before us as the telecom networks expand and get wider and wider uses and use cases. I think this workshop is also very timely in the sense that there is varied experiences on artificial intelligence, and probably only we have just seen the beginning of the various the benefits of using artificial intelligence. So therefore, there are a number of large operators who might be using or are using artificial intelligence very effectively, while there may be several other categories of operators, not necessarily telecom service providers, but also internet service providers, maybe VNOs, maybe several others could also deploy such kind of technologies to actually enable better services and also to enable improvement in their efficiency. So if you look at the benefits of artificial intelligence, I think all of us, before we go into AI, the thrust in the modern world has been the pressure of competition. I think as more competition becomes more and more intense in all these services, the pressure is on reducing the costs, cutting costs in whatever manner that we would want is the way to go to ensure that you are the service providers are able to generate profits and margins in the competitive market. So cutting costs is one. The other thing is also greater and greater expectation from the marketplace, from the customers. Customers expect better services, more customized services, better experience, better quality of service, and so on and so forth. So therefore, all this requires a greater understanding of the customer himself or herself. So that maybe for that it requires a greater amount of an application of mind, and AI will come in very useful to get an understanding of consumer behavior and how the service provider can enable provision of services in a manner that actually benefits and is appreciated by the consumer. So from all these perspectives, I think applications I think are as much as we can apply our mind to. The biggest advantage that we see in India is that India is the home to an extremely large set of information technology companies. So we have the capabilities to apply information technology tools, of which AI is one, to actually to our national benefit. So from that perspective, I feel that this is a great opportunity in actually creating an AI layer over telecom service networks to enable provision of better services, differential services, and so on and so forth. So the first one is obviously, the first item is obviously, as I said, to reduce the costs. At the end of the day, I think we need to, the industry is known for investing very heavily in the capital expenditure for setting up networks, both in the hardware, software, etc. So essentially, managing these resources will require a large amount of application of mind in ensuring that these assets are run efficiently, in the sense that the operational costs are brought down. Essentially, if you look at things like, say, management of the power, the power consumption in telecom networks is a big challenge. We are today talking of green telecom. So I think use of AI and ML will enable fine-tuning the power consumption by various telecom equipment across such very large networks to enable optimizing the power costs. So this is just an example. There may be several other cost elements which could be optimized based on use of artificial intelligence tools. The other thing is obviously, the use of the network efficiently. I think we have seen the intensity of traffic in different telecom towers and so on and so forth keeps on changing with every second. So therefore, if there is I'm sure that telecom companies already are deploying tools to find out how both their transport networks as well as the consumer facing front haul can be used very efficiently. So in such a situation, I think use of artificial intelligence enables optimizing the utilization of the network elements in a manner that actually provides the what you call as a standard quality of experience and service to the consumer. Because essentially, as traffic varies, consumer experience also varies. So therefore, I think this use of artificial intelligence can actually reduce this kind of fluctuation in the quality of service and so on and so forth because of variation of traffic. Similarly, I think it could look at improving the resilience of networks. Essentially, when you have things like disasters or accidents and so on and so forth, maybe networks can become more resilient if AI is used to actually to ensure seamless provision of services without interruption when such kind of incidents happen. Similarly, I think if you look at it, as I already mentioned, I think the consumer experience today is a big challenge, definitely, because of two reasons. One, as the networks become very big, the quality of supervision over the networks also becomes difficult. So essentially, manual supervision becomes just like it's an impossible task. So therefore, it is nothing but automation that can actually support maintenance of the quality of service. So essentially, therefore, things like, say, robotic process automation, things like, say, chatbots, and so many ways in which I think the consumers can be reached out, I think requires use of artificial intelligence to enable that consumers are handled effectively, efficiently, and in a manner that actually enhances his experience. So from all these perspectives, we have a lot of opportunities, and I'm sure I'm seeing a lot of these telecom companies and internet service providers and so on and so forth utilizing these services. But I guess more needs to be done. I think if you look at it, what needs to be done, I think, first of all, I think there needs to be improvement in the capacity of various service providers to understand the applications of such kind of artificial intelligence tools in enabling provision of better services. So I am sure that many of these small operators would require greater amount of support. They will require capacity building and also probably exposure and also assistance in kind of deploying such kind of tools. The larger ones, obviously, when they have access to cash, and therefore when they can definitely reach out to more people, reach out to the right resources effortlessly without any help. So now, similarly, I think if you look at, there are some other areas like, say, prevention of fraud. I think today, most of our consumer data, personal data, non-personal data, all of them reside on, are afloat around through telecom networks. So therefore, prevention of fraud is a very, very big challenge. Department of Telecom is working on systems like DI, Digital Intelligence Unit, TAFCOP, and so on and so forth. And I think even there, I think there is a tremendous use case for artificial intelligence to be deployed to ensure that we, in a manner, effectively prevent fraud rather than actually going after fraudsters. I think so. I think that should be the way forward. Similarly, I think there are many other use cases like, say, predictive analytics, predictive maintenance. There are so many ways in which I think not only in the telecom sector, every other sector I think uses predictive maintenance effectively through AI and ML, in a sense that you prevent breakdowns through better monitoring and use of AI tools and so on and so forth. So these will obviously reduce the outages, improve the availability, enhance better customer experience, and so on and so forth. So at the end of the day, I will end by saying that NTIPRIT has done a fantastic job by organizing this workshop. I would request that that a very active discussion must be held at the end of the presentation to enable us to kind of summarize and crystallize the ask. I mean, I think that is before us, and also try and see how every one of these stakeholders can join hands to actually deliver a part of this additional value that can come into the marketplace. So I would request NTIPRIT to the proceedings of today's workshop, and also share it with all the stakeholders, and also come back to us, so that we would be very happy to support and facilitate it. Other ministries like METI and others also could help in kind of supporting the proliferation of AI in telecom settings and so on and so forth. So I would also say that we should also use this opportunity to spawn a new generation of startups to actually develop some tools. These tools which can ride on the existing telecom physical and the soft layers of the network. So therefore, I guess a lot of innovation can come in here, and I see great opportunity for creation of jobs, and also great opportunity for providing greater security, lesser fraud, lesser pain for the consumer, and so on and so forth. So with these few words, I thank all of you, and I hope that this workshop deliberations lead to greater understanding and clarity on the way forward. Thank you, and looking forward to more such interactions. Thank you all.
Thank you, sir. Thank you so much, sir. Request you to declare the webinar open, sir.
So I'm very happy and to declare the webinar on artificial intelligence use cases in telecom open, and I also congratulate the NTIPRIT DG and others for this great effort. Thank you all.
Thank you so much, sir. Thank you, sir. Thank you for sparing your valuable time from your very busy schedule, and also sharing your thoughts with all of us, and also for declaring the webinar open. We are very grateful to you, sir. We are very fortunate to listen to your inspiring inaugural address, wherein you have mentioned the importance of the webinar topic. Once again, thank you, sir. Thank you for your gracious presence. So now we have come to an end of this inaugural session. First and foremost, I would like to profusely thank our Secretary Telecom and Chairman DCC, who despite his busy schedule has spared his time and joined the inaugural session and also declared the webinar open. Thank you, sir. Secondly, I would like to thank Member Technology, Member Services and Director General Telecom, who have spared their valuable time and joined the inaugural session. Thank you, sirs. Last but not the least, I would like to thank our Director General Telecom, Shri Srivastav sir, who is also head NTIPRIT. Sir has been a great source of inspiration to all of us at NTIPRIT. It is, in fact, he has been the driving force behind this webinar, and he has provided us a lot of support and help to, what we are seeing today. So thank you so much, sir. And with this, we have come to an end of this inaugural session. So now, next, we go to the technical session. In the technical session, we have 5 sessions altogether on different topics. We have expert speakers from Ericsson, Intel, Reliance Jio, CDoT, and COIGN, which is a startup company. So I request all our expert speakers to stick to the allotted times so that we can conclude the whole thing in the allotted time. And my also request to all the participants to keep their microphones in mute condition. And if there are any questions, please message your queries, or you can also raise your hand. So we will address all the questions and answers at the end of the session. So the first section will begin with our guest speaker from Ericsson, Mr. Jayaram Beladakere, and the topic is transforming telecom through AI. So I'll just give a brief introduction of Mr. Jayaram. Mr. Jayaram is from Ericsson. He is based in Bangalore, and he has 25+ years of global business strategy, product planning, and full life cycle management with specialization in telecommunications. So he has deep expertise in service providers, enterprise and cloud networking, and is well versed in IoT technologies and solutions, including go-to-market aspects, co-development models, and emerging market needs. Currently, Shri Jayaram leads technical product management function in Ericsson Global AI Accelerator in India. In this role, he is responsible for building AI ML solutions for the different business groups and marketing selling units of Ericsson. His work covers all parts of mobile operators life cycle like design, rollout, optimization, and service assurance. He is leading the global and strategic industrialization initiative to drive company-wide maturity for supporting at-scale deployments and life cycle operations of AI-based solutions. So over to you, Mr. Jayaram.
Thank you. Thank you for the introduction. Let me start by sharing the presentation. I think the topic was well introduced by Director General Sri Srivastava as well as Honorable Secretary Rajaraman. So it's a pleasure to present Ericsson's views on how artificial intelligence and machine learning technologies are transforming the telecom industry. So my brief presentation will talk about the business reasons and the rationale for bringing in these kinds of tools into various aspects of the telecom business and Ericsson's approach to incorporating AI into its portfolio. Then I will close my presentation by presenting a set of use cases which describe applications of AI in network design and optimization, network operations and management, as well as the future so-called intent-based networking. So the motivation for considering new approaches like AI and ML is highlighted by the chart that I am showing you here. The operational expenditure is shown on the y-axis, and on the x-axis are the various generations of mobile technologies going from 2G, 3G, 4G to 5G. And in that journey from 4G to 5G, we also began to see several important trends. For example, in disaggregation of network elements through software-defined networking and network function virtualization. 5G, the radio access network itself, as well as the core infrastructure, that is now formed out into components which can be distributed in various parts of the infrastructure and the end-to-end solution put together. Use cases in IoT domain, customer and consumer experience management, as well as new verticals, which include, for example, 5G for industries or private networks. So all of them, they bring in an order of magnitude more complexity in building and managing these networks. So given the status of the revenue streams that the operators have, the average revenue per user, which is stagnating, they need to bend that OpEx curve, and that is what is shown. And that drives the need for automation and AI in our industry. So this is the backdrop against which we will be looking at the technologies of automation and AI. And from Ericsson's point of view, when we look at the end-to-end network and the architecture on the left side, you are able to see both mobile devices as well as some of the other use cases like drones, vehicles, self-moving, cranes, etc., that are on the left side. And on the right side, you are finding applications and services which may be delivered from the cloud. And in between is this infrastructure which spans the access network. Then you have the transport, which can be front haul, mid haul, back haul. Then you have the cloud infrastructure, which is provided by the infrastructure layer of the cloud itself, as you're able to see here, as well as the cloud core and cloud communication services that are made available here. So all of these, need to be managed and orchestrated in a distributed fashion. So you have that layer, and on top of that, you find the billing and charging systems that companies need to have to address not only current use cases, but also the future use cases. So all of these, including the need to, in fact, deploy and manage these through network services, in every one of them, we find reasons to deploy AI and ML kinds of technologies for different objectives. And I will come to that in the next slide. So having seen how AI impacts each and every piece of what a company like Ericsson does, as well as our telco customers, how do we see AI? So customers, if you look at telcos, they have at a high level, one can look at 4 different areas where they need to focus on. Efficiency is a very important consideration for them. So improving both the operational aspects as well as the CapEx part of it. I think we already heard about the need to maintain high level of consumer experience. So understanding the consumer and providing the right experience for the consumer for the diverse range of use cases that are now used by these consumers. Network performance and how it contributes to overall consumer experience is an important consideration. We need to move away from looking at metrics that are, say, network-centric, KPIs that are network-centric, to more user-centric. How do you get on that journey and be successful in that? Fourth, we already touched upon newer use cases that will be leveraging 5G and IoT. So how do you, it could even lead to new business models, as a service kinds of models, new entire verticals that one could be looking to build. So all of these require us to consider how do we bring in AI and ML together to empower both people and machines to transform what has been traditionally be an engineered network to a learning network. And these are in fact built on 4 components that we consider them as foundations. AI and ML, we need access to data. That's why we have a high priority data ecosystem. Technology leadership in understanding the applicability of different AI and ML approaches to our industry, telco native AI, and how do you really get on that journey in future products. Then competence to leverage the AI/ML technologies as well as the telco domain expertise that we have in being the market leader. And finally, I think a very important part here one needs to consider would be how do you, all of this, there are so many issues related to trustworthiness in AI. It could be about transparency, it could be about security, it could be about fairness and being free from bias. So the giving access to the data, national sovereignty requirements. So all of the trust framework. So all of these are foundational capabilities. So with that, what I'm going to first do is give you a high-level picture of the applicability of AI and ML in the mobile industry, and then I will get into very specific use cases. So if you look at the radio access network, where a lot of the investments go, this includes the RAN, the transport. So we already heard about the energy efficiency considerations with the 5G, massive MIMO kinds of technologies. How do you leverage AI to drive energy efficiencies, not only on the radio infrastructure side, but also in site operations? How do you leverage AI and ML for doing load management and mobility management? How do you harmonize the network in such a way that radio access as well as the transport, different parts of the transport, work seamlessly end to end for maximal benefits to the end users? And how do you do radio resource optimization in very dynamic and changing conditions where diverse set of traffic uses and are burdening the network? So that's one part. Second part, as we look at the core part of the infrastructure now, this could be the packet core kinds of infrastructure. It could be the billing and charging kinds of systems. As we know, now these kinds of nodes already even in the world of 4G, they are getting distributed. So distributed into, for example, containerized microservices, which may be running on a virtualized or containerized infrastructure. So when you have such a model, overall business process level metrics, how do you manage those? How do you do troubleshooting? How do you do incident management? How do you optimally use the resources when the traffic demands may vary over time? How do you ensure high availability and robustness? So all of these are central considerations. Then you are talking then about network planning, network design, and optimization. So how do you plan the network and design the network? For example, if you already have a 4G infrastructure, can you do, say, computer vision based solutions around the planning of the 5G network? How do you do the provisioning of the radio spectrum and manage the radio infrastructure in an efficient fashion? How do you maximize customer experience? In the operations area, a big part of the cost will be in handling the tickets. So how do you automate some of that and enable the front office and back office teams to be much more effective in the way they resolve these tickets? And in fact, by, for example, providing recommendations on the kinds of solutions that may work. Finally, there are newer use cases. We already mentioned some of them related to Internet of Things, related to end-to-end security, the threat management, connectivity management, private networks, network slicing, and such. So all of these areas, the end-to-end considerations, all parts of the end-to-end network and all aspects of, say, from design, deployment, optimization, and management can leverage AI and ML. So with this as a very high-level overview, I will give you examples of some use cases that we have delivered. So the first one, this is network design related use case. So RAN design method. It's a complex challenge to do this radio access network design. And on the right side, you see a picture where big data analytics was applied because you need to try out different combinations of the radio infrastructure. So by using AI and ML in this ERAN design to maximize end user experience, as you are saying, 100,000 plus cells are analyzed in this particular case. There was performance boost of 120%, and the time saved in the design was 40%. At the bottom, you can see, the highlighted area. So this, the 4 buckets that I talked about from the telco perspective, what are important to them. So this contributes to relentless efficiency, maximizes end user experience, as well as improves network performance. So this is one specific use case. A second one, this one talks about an operational network. Now you are looking at how do you do optimal traffic distribution in a radio access network. So in this situation, you want to do traffic management that is driven through policies. So you want to achieve the desired traffic distribution across the different bands, as you're able to see here. There is a basic band, a legacy band, and an evolved band. And there is a policy that tells you how much traffic should be on each of those bands. So how do you drive traffic distribution using AI ML technology? And so considering the available band for each UE and monitoring loads in real time. And in a future slide, I'm going to touch upon another variation of this, which we delivered for an Indian customer. So you'll hear more about that. So this contributes to efficiency as well as network performance. Third one, this is related to incident handling, ticket handling that I was referring to. A very big part of the operations and service level assurance. So a typical network operations center, like you get thousands of tickets sometimes, per day, and you get many threshold crossing alerts, alarms, and such. They keep coming up. And so what can you do with, for example, the value of AI/ML here is understanding, how do you really do correlation across events that are being reported at different layers of the network, but slightly different times, probably in the same window of time. And how are you able to do cross-layer and cross-network element and cross-stack correlation and then drive resolutions at the level of an incidence rather than at, say, addressing each and every say alarm or alert that you are getting. So this again contributes to efficiency and network performance. Finally, there is one more here. This one is an interesting use case. What we are doing here, this is a network where we are looking to see, predicting 4 hours in advance, what is going to be the traffic pattern that we are looking at. And you have various cells in this network, and some of them more probably are more heavily loaded than some others. So in this particular case, what we are looking to do, you are able to see some of the methodology here. There is data labeling, correlation, and prediction. And once we are finding that a cell, which is a source cell that what we are talking about here, is likely to experience performance degradation across different KPIs that are of interest to an operator, and can you identify nearby target cells which is in a good shape, and then you shift the traffic and drive that through a closed loop automation. And as you're able to see on the right side here, we are able to do this by successfully using closed loop automation, and it results in superior user experience, through higher users that are using the infrastructure, improved network. So for example, throughput, downlink throughput is the metric that is being used here, and improvements in the payload itself, optimum spectrum utilization. So this is another use case related to network operations. I have one final use case, a little bit future kind of use case. I thought it could be relevant here. So I will play out the complete animation. So think about the value here, like you have, I want to maximize the VoLTE experience in Manhattan. So that is the objective from the operator. So you have both the reasoner here using machine reasoning, and you have the trained ML model, which is used as, you can look at it as roughly as a digital twin. It understands the business intent, converts them using knowledge reasoning to KPIs that need to be changed, configurations that need to be changed. And so ML agent, that can optimize the configuration. And then you model the network and see, what happens. Does it give you the right expectations and the results, and evaluate the different options? And the reasoner then says, OK, I want to make these changes and implement that through a closed loop system. So this is a rough example of intent-based networking that we are all interested in, and how a use case could flow from business, in fact, intent that is stated as maximizing VoLTE service to a network configuration, and then it monitors that and see, what happens, across, and that you can monitor that. So with that, I think there is one final slide I want to talk about. How do you go about achieving all of these targets? An offer that Ericsson has to satisfy this is the Ericsson operations engine. And we talked about 3 dimensions. One is the more complex networks to operate, traffic and devices that are increasing on this side, and then diverse services which are leveraging the same network. So you need 3 pieces in this here. One, the core components that you are able to see here, AI components, automation components, data, inferencing and applications. And let's not forget about people and process. So they constitute the very core components here. Then we have the capabilities around them. So once you have the core capabilities, how do you drive automation intelligently, and how do you do security? How do you establish collaboration? How do you drive smart design? So all of these are the capabilities that you can derive from the core components. Finally, business outcomes like technology transformation. You can do optimization of costs. You can grow revenues. You can maximize customer experience, and you can shorten the time to create new services and have a network that is trusted and secure. So that concludes my presentation. I once again want to thank DOT NTIPRIT for this opportunity. Hope that you found this useful. Back to you.
Yeah, thank you, Mr. Jayaram. In fact, it was very useful and informative. In fact, we should be thankful to you that you could spare your time and come over here. So thank you so much. Our next speaker is from US. She's from Intel, Mrs. Meena Arunachalam. Sorry, ma'am. Actually, I mean, it's an odd time for you. Thank you for sparing your time. Just a quick introduction of Meena. So Meena is a PhD and she is working as director and principal engineer. Is an end-to-end AI performance architect in AIA, Artificial Intelligence and Analytics Group at Intel Corporation, US, and works on AI ML software architecture for compelling end-to-end AI data pipelines in vision, video, recommendation, ML, NLP, and others. AI use cases with Intel Xeon CPUs and accelerators. She heads a team that focuses on end-to-end AI performance optimizations, hardware software co-design, and workload performance modeling. Her research interests include efficient AI, AI at scale, and heterogeneous computing. She has authored more than 20 peer-reviewed publications in IEEE and ACM conferences and journals, including 2 book chapters in High Performance Computing Pulse Volume 2, and has 4 issued patents. She has given several technical talks at various events, Databricks AI Summit, DICE 2021, SAP Tech, etc. What do you, Meena?
Thank you, sir. Thank you for this opportunity. I hope you're able to hear me okay. Yes?
Yeah, we can.
Okay, and you're able to, are you able to also see my foils?
We can see the slide also. Please go on.
Wonderful. Okay, let me get going. So first, today my talk is going to be a little bit different from the first speaker. I work in this group that does AI software optimizations and solutions. And I'll talk a little bit about software optimizations, and then I will talk about a few customer telco use cases as well. Okay. So let me know. Okay. So this is sort of the end-to-end AI software suite that we like to look at, and we optimize for this. And this is basically, think of it as your, as you're creating any kind of AI pipeline, you have data engineering, data ingestion, data wrangling, cleaning, and such that you do, followed by you create your own, build your machine learning or deep learning models. And then sometimes it's an iterative process that you go through many times. And then finally, once you've decided to train the model, you deploy the model and you do inference. Along the way, you might also have in the deployment phase some ML operations. So if I think of the life cycle of AI, this is what it is. So typically, so what Intel offers is a lot of the popular deep learning packages and frameworks like TensorFlow, PyTorch, MXNet, all Intel optimized with Intel optimizations, as well as things like Scikit-Learn, Xgboost. These are very popular classical machine learning or Xgboost or LightGBM and other packages. We optimize for our Intel architectures. Similarly, we have data analytics at scale with Modin, Pandas, NumPy, and various other packages. And we also offer the various additional tools that you can do further optimizations on your models, such as SIGOPT for AutoML or model tuning, automating low precision optimization with something called Intel Neural Compressor. I'll come to it in a minute, when you can actually, with neural networks, you can go even lower precision than 32 bits. You can just do 8-bit computations, right? So you're going to save energy, power, and as well as improve performance, right? Within and the Xeon CPUs support them. And then you have this another OpenVINO toolkit, which is Intel's own deep learning framework. In addition, we have the Spark Big Data Analytics platform. We have something called Big DL and AI, and I'll talk about that with some telco use cases, as well as with all these various deep learning packages. At the very low level, we have things like OneAPI, OneDAL, OneDNN. These are the low level libraries for the various deep neural networks, data analytics, and so on. And these span all the way from your laptop or workstation to server, cloud, and all the way to the edge. So let me show you this slide is just collection of all the different hardware offerings Intel has. The Intel Xeon, which is the workhorse in the data center. It has something called the Intel Deep Learning Boost instructions, which really automate and make deep learning go super fast with specific ISA instruction set architecture like vector neural network instructions, followed by we have something called advanced matrix extensions, which is going to be part of our next product. We also have our own Intel Z GPU or Xe GPU that is coming out soon. And then we also have invested in Habana, which is already an accelerator for AI that is hosted on Amazon today, and other CSPs coming soon. We have Movidius, which is like the edge offering for AI. And of course, all of this entire suite of software that I showed you earlier runs really well on all of those. So let me quickly show you what I do on a daily basis in my job, and then I'll tell you how it applies and matters to you, and especially to the telecommunication or anybody who wants to use AI. And particularly, I'll end with some telco cases. So typically, the modern hardware, parallel hardware, has lots of cores, lots of threads. It has vector units, and you have to be very smart about how you manage memory, and you can do graph optimizations and such. So across all of these libraries, TensorFlow, Python, Xgboost, Modin, name it, all of these need to get parallelized. They need to utilize all the cores and essentially get the best vector performance, use single instruction, multiple data instructions to get best vector efficiency, even things like convolutions, ReLU, batch normalization, these deep neural network operations, they need to get optimized through the deep neural network. So if let's say on the right side, you see, if this is my roofline, what is possible with the machine? If I just use the FP32, 32-bit baseline stock software, this is the performance I'm going to get. Now, if I go do further optimizations with 1DNN, I can get to 85% improvement. If I can do further and go to int8 precision data type, I get another 70%. And if I use the hardware support with DL boost, I get 160% boost, getting it very close to what the hardware roofline is possible, right? Okay, so now let me go to the next foil. I'm going to show you just one example. I don't need to go through this for everything. Here, I'm showing you a couple of models, deep learning models. One is ResNet 50, which is an image classification model. Another one is deep learning recommendation model. Both are neural networks, deep neural networks. There is a 53x gain in performance by merely using the optimized Intel PyTorch. So what we have is something called Intel PyTorch extensions. So while we upstream the optimizations into PyTorch or TensorFlow, we sort of put it in a place which is IPEX. So with those optimizations, this is what I get, right? Eventually it gets upstreamed, about 53x improvement on the exact same hardware. And similarly, 4.5x improvement for DLRM. On the right-hand side, I'm showing you the different Xeon architectures. Today, we are at something called Ice Lake, which came out after Cascade Lake. And then in 2021 or to end of or early mid 22, we will be launching Sapphire Rapids. Okay, so let's, without spending too much time, this is another chart for TensorFlow, which is also something, we optimize, but I will quickly run through this. I want to show you Scikit-Learn, which is another extremely popular library that gets used with a variety of, statistical approaches, regression, decision trees, all kinds of things for classical machine learning, clustering, whatever different algorithms. And just by using the Intel optimized Scikit-Learn, you can get this big boost in performance. So it's literally 2 lines that you need to add. You import this patch for Scikit-Learn, and then voila, you see this humongous performance improvement. So here you can see that we are showing this for a variety of algorithms, both for training as well as for fit as training, and then predict as the inference models. Similarly, you probably have come across Xgboost, which is an extremely popular extreme gradient boost machine decision tree based package. It's an extremely popular one. And here too, you can see on the left, you can see pretty much with every release of Xgboost on different data sets, we are seeing tremendous improvements in performance. So all this, our goal here is to upstream all our optimizations, which is what we do. So get the latest and greatest and you can optimize. Further, you can use the one DAL or the one data analytics library inference engine underneath. And then you can invoke this every time you're doing inference so that you're not doing data conversions between the Xgboost and DAL. And you can see another like 30x or anywhere from like 10x to 30x improvement. So clearly, I think I made my point by now that everybody should be using optimized software. What else can you do, right? You can use what is called INC. It is a Intel neural compressor. You may have heard of this concept called quantization. So what does that really mean? Traditionally, what happens, all our models run with 32-bit code, floating point 32-bit in deep neural networks, right? But now, a lot of research has shown that we can actually reduce in many neural networks the computations to 8-bit computations. A lot of the activations, the weights in a deep neural network can just manage with 8 bits. That means you're reducing the amount of energy by 4x, you're reducing the amount of computation, the amount of data movement, and essentially you can make the machine a lot more efficient. And this is a very popular approach that is followed in the deep neural network area. So this, what typically happens is you have a 32-bit model. Now you need to do what is called quantization. You have to go calibrate with the data set that you're going to be using for the model. There are two kinds of training. One is called quantization aware training, one approach. Another approach is post-training quantization. You can do either one. And INC tremendously improves your productivity by 18x with very simple model calibration, effective model calibration, advanced quantization recipes, and as well as auto-tuning workflow. You can really get to business really fast. But what does it really mean? What happens when I go and quantize the model, right? So below here, you also get a huge boost in performance. Typically, there will be a small loss in accuracy, but as long as it's less than 1%, most customers are fine with that. And that's what I'm showing you here on the right below. So on the x-axis, I have the accuracy loss, and the y-axis is the performance speed up. You can see that for a lot of the models, you can see anywhere from a geo mean of 2.2x improvement and some as much as 4x, which is your theoretical peak. And here I'm showing you with stock TensorFlow on the Ice Lake generation of Xeon CPU. We are at a baseline, let's say FP32 performance. Then we add the 1DNN optimizations, and further with the INC quantization optimization. Plus, if I do the next generation CPU called Sapphire Rapids, I'm getting from one generation to the next, I'm getting a 30x total performance gain. This is just unbelievable, super fast. Xeon is a general purpose CPU, but yet you can still run really good workloads. So let me give you some workload examples. I'm going to start with one I think I have heard some network providers are interested in. One such one is called a natural language processing document level sentiment analysis. In this workload, we use what essentially is done is the documents that come through, you classify them and classify the sentiment of these documents. You can also do what is called document classification. You can do text analysis. You can do a variety of models, but I'm just showing you one example for a document level sentiment analysis. So here you have two pipelines or two phases. One phase is where you do what is called fine tuning, or fine tuning is essentially taking a general purpose state-of-the-art model that is there, trained on a general set, and then customizing it without training from scratch, because training is a huge power consuming, energy consuming operation. It can take many, many hours and it can consume huge quantities of energy. So something like a BERT model somebody had done, it takes the amount of energy to train a BERT with billions of parameters. It can take anywhere from, like 10 cars worth of, carbon, right? Emission can happen when you train the model. So a lot of the industry best practices are to take existing pre-trained models from what is called a model zoo, and you do what is called fine tuning. Fine tuning is you take a general purpose model and then you tune either all of the weights in the model or a portion of the model, and then classify it or tune it for your specific task. Okay, so this will be much faster and it'll save you a lot of energy and time. But it works really well in vision as well as in natural language processing. These are the two arenas where it's well used. It can also be used for classical machine learning, but classical machine learning is not as computation hungry as deep learning is. So here we go through the fine-tuning pipeline. We go through tokenization, feature extraction, load the model, and then do the fine-tuning, and then eventually pass it on to the pipeline below, which is the inference pipeline. So what I want to show you is one example of, I'm going to skip this one in the interest of time. I'm going to show you this example where we took, like what I showed you earlier, by doing multiple instances on a Xeon CPU, I'm able to get, and with my optimized libraries, which offer higher vector efficiency, fusion, like things like batch normalization, matmulls, these were fused and better caching of weights. And then also doing auto mix precision, where I can do some in bfloat16, some in FP32, and even further with 8-bit quantization, I'm able to get a total optimized performance of around 3.36x from baseline to optimized software. So this is tremendous. So let me talk about another use case. Actually, I'm going to skip this and I'm going to go straight to the telco use case examples. So I wanted to talk about two customer use cases. One is South Korea Telecom, which is the one of the largest mobile operators in South Korea. And my team, I have a part of my team that works very closely with customers. We go armed with all our software and our solutions and go work hand in hand with the customers. And we welcome any such collaboration with any of you as well. So this South Korea manages, like Telecom manages around 400,000 cell towers with over 27 million subscribers, and their network handles roughly like 120 billion records per day it accumulates, and then 1.4 million records every second. This is how they record for the network quality prediction and various other purposes. I think the earlier speaker mentioned KPIs, key performance indicators. So a lot of data telemetry happens. I'm sure you're all aware. I'm not an expert of telco, but I'm an expert in AI, but I can apply it for the telco use case. So two use cases. One is network quality prediction. The other one is privacy preserving machine learning. So in the network quality prediction, I'm sure you're all aware, we use, in this particular case, we offer something called big data analytics. I'll show you in a minute. We use a time series method, which is the popular approach to use to predict what, based on the past, you predict the future. And then for privacy preserving machine learning, where you're offering a complete secure end-to-end machine learning approach, that also I will show in their edge case, the 5G edge servers, they show this. And we showed with them. And then another one is Asia Info. Here, I think the inaugural address said about energy efficiency. With AI, we were able to significantly improve their energy efficiency of their base stations. So let me show you. So we have this particular library or software solution called BigDL, which has essentially multiple different domain specific solutions. And I think particular of interest will be Chronos for time series and PPML for privacy preserving machine learning. So the underlying uh, infrastructure that it's built on is the big data Hadoop or Spark infrastructure, upon which we have two libraries. One is called Orca for distributed TensorFlow, PyTorch, or OpenVINO on big data, and DLLib, which is for distributed deep learning framework for Apache Spark. So, how did we help SK Telecom? So in this particular case, they were doing two things. So they would do all the big data analytics, the data lake warehouse and the big data cluster, and do all the data management on the Hadoop cluster, the big data cluster, Spark cluster. And then they had a separate cluster of machines for TensorFlow or PyTorch for running their deep learning models. So this was pretty inefficient in the sense you were maintaining two sets of hardware resources. Instead, BigDL combines it together because the way CPUs work is, especially with Xeon having more and more AI capabilities built into the general purpose CPU, now it's able to do both, the big data analytics, and on that same in situ in the same cluster, we are also able to run our deep learning tasks. And with the Chronos library, like I said, it has various different algorithms and prediction algorithms built for time series, and as well as some auto ML capabilities. Okay, I'm not going to go too much into detail into it, but I'll show you what the use case brought for the customer. So in this particular case, this was trying to predict the network KPI forecasting. So you can see the blue line was the actual value and the red line is the predicted value. They're very close. And the notebook links are all here. If you want to look at, we tried both the forecaster model and the auto TS model. Of course, these are with simple data sets and not the proprietary data sets or anything we are using here, right? But the customer net result was that the customer saw that with the unified CPU cluster, they were able to reduce their inference time by 3x, and they were able to increase the training throughput by 30 to 50%. And this was a very scalable design. So they have something called a flash store, which is an big data database, and then upon which they're using our CPU only cluster. Mind you, this is only CPU only cluster, a unified cluster, and they were able to get better performance and better performance per dollar, better performance per watt compared to a two disjoint CPU plus GPU cluster. So the model that they used is a memory augmented TensorFlow model. It's basically a deep learning based time series model. And I have attached the paper here. It is called a memory time series net, MTNet. The model takes two inputs, last 50 minutes of network KPI data, as well as last 7 days of network KPI data. And based on this, it makes network quality prediction for the next 5 minutes. So if you read this paper, you can get the full architecture, but this is what we implemented with the customer. Again, here is just some results. We are showing a distributed CPU cluster, a distributed GPU cluster, and on the right, you can see that with starting with Python processing on the GPU, how you can actually go all the way to just CPU only. And with Analytics Zoo, you can get a substantial improvement in the inference time on the right, as well as substantial improvement with different batch sizes on the training side. Okay, so this is a clear, beautiful poster child for doing CPU-based training and combining big data and deep learning together in the same infrastructure. So the next one is same thing with SK Telecom. In this particular case, we were doing a privacy preserving machine learning. It's a MEC platform. It's a mobile edge computing, common for 5G services at the edge in the mobile telco network. Here we use a particular feature or instruction, hardware instruction called the secure guard software guard extensions. So these basically give you an enclave, a secure enclave within which you can store your memory. So basically, it's a POC that they did with us, and for confidential computing for both your data and model protection. So you can do, you can extremely highly confidential data and model that you do not want to share. You can, put it inside this enclave, and we provide the PPML vertical solution as part of the, the big DL library as well. So this secured images per second we got for this particular use case that they had, and then we also improved the throughput. So another use case, and I'll close with this, is Asia Info. And here, this particular use case was about, I think, 3 things we worked with them. One was to improve their, higher dimensional time series forecasting for automated power savings in their base stations. And then also low efficiency tower shutdown and long-term low efficiency tower retires, right? So these were the areas that they wanted us to come and help. Using Xeon and Big DL, as well as, I believe in this case we use TensorFlow. So we built a deep learning model for them, as well as a data analytics model, time series based model, and then we accomplished all of this. So let me give you a little bit of details. So here, the AI-based solution, like I said, we were able to get a reduction of data pre-processing time by 3x and prediction accuracy by 2.5x we improved compared to the customer's original solution. So the customer was using, I'll show you in a minute what that solution was, but we were able to improve upon it using our approach. And as a result, they were able to increase the power saving accuracy by up to 15% for their 5G based base station scenario. So again, like I showed you earlier, this is their time series based data and a history of KPIs they collect over a period of time. And this is the customer models, mean absolute precision error that you're seeing here. And then this is our approach, and we are like at least anywhere from 7% to 15% better. And again, using this, a model from our Chronos model, right? Okay. And lastly, I want to close with one foil which shows you we publish a lot of different benchmarks. And with, I think with Alibaba and Lenovo, we have published TPC-X Big Bench, which is a big data analytics benchmark. We have had 11 world records on Xeon, and we also have publications on MLPerf, which is a deep neural network library. Again, here as well, we have published 100% model coverage, and we get better efficiency, software efficiency compared to accelerators or GPU solutions. So I want to close with the fact that, there's a lot of different, solutions and software optimizations and packages that we can offer. And I hope you can also benefit from it, and look at download the One API Intel Analytics Toolkit, AI Analytics Toolkit, and play with it, the Big DL or Analytics Zoo, and play with it and benefit for your use cases. Thank you for your time, and back to you.
Thank you, Meena, for that wonderful presentation. It was quite useful and very informative. Senior officers and friends, Meena is actually in a different time zone, so maybe she would like to leave the session after this. So if there are any quick questions related to her topic, so we would like to take them so that I mean she's at liberty to leave the session if she wants to.
Sure. Yeah, I'm happy to take.
Is that okay? Is that okay, Meena?
Sure. I'm happy to take some questions. Yeah. As long as you are fine with the time. Yeah. Quick questions.
Siddharth?
Hello, sir.
Yeah.
Anybody who is having question, they may either post it in chat or raise their hand. And
either it was very clear or it was too fast. I was trying to cover a lot of material. Okay, let me ask you guys some question. What is your favorite deep learning package that you guys use, or what is the analytics? What solutions do you use? Anybody dabbling with AI? I'm sure you guys are. TensorFlow, yes, good. Okay, that's probably the most popular deep learning package, like hundreds of millions of downloads in a matter of less than a year we see for TensorFlow. Yeah, that's popular. So please do download our Intel TensorFlow extensions, and I will share the slide deck with Kishore and the organizers, and yeah, and hope you benefited. Okay, I believe there is one hand raised. There is a question.
Rahul Ratnakumar. Siddharth, kindly give him permission to speak.
Yes, Mr. Rahul, you may unmute yourself and you can speak now.
There is one more.
Am I audible, ma'am?
Yes.
Okay, thank you for the nice talk.
Mr. Rahul, go ahead.
Yeah, thank you for the nice talk, ma'am. So, ma'am, can you tell me about one of the hardware configurations, especially for real-time signal processing? Actually, I was knowing that Intel has acquired like Altera. So for real-time fraud detection and all those real-time processing, which one is the best model which you prefer in terms of hardware?
So the Sapphire Rapids, which is the general purpose CPU that's coming up next, that will have advanced matrix extensions and what are called the tensor cores for doing these massive, matrix multiplications. So that is a general purpose CPU that can also run AI, right? But the Altera, the FPGAs you're talking about, you can custom code the models in hardware itself. That's what FPGAs are known for, right? So it depends on your particular use case. Do you want to try out variety of models, or are you wanting to build some custom models, right? FPGAs are very energy efficient, but they're also, you have to program them, right, into running these models. So it totally depends on your use case.
Okay, thank you, ma'am. Thank you so much.
Yeah. I think there's one more hand.
Yes, Mr. Mufti from GMBSNL. You may unmute yourself.
Yeah, good afternoon to you from our time standards. So I'm Mufti here, and the question is very simple. It's about, what is the horizon, or rather, where are presently we in as far as AI is concerned, and what is the horizon? A lot of things are being told that AI can do this and AI can do that, and a lot of science fiction is also associated with it. In the next 5 to 10 years, things will be taken over. Sometimes it gives you a sense of that Terminator thing, happening. So can you throw some light on that?
Sure.
Yeah.
Absolutely. I don't think human beings are ever going to get replaced, for sure. What I believe is AI is here to help the human, right? Like I think the inaugural speaker or one of the speakers was saying the network, it used to be network centric, now it's going to become user centric, right? So you can customize things more and more to the user, right? So
Yes.
ultimately that is the power of AI. Yet there is a vast field. By the way, I'm starting some research in this space called explainable AI or responsible AI. Almost on a daily basis you will watch news articles which say AI has done this, the car has driven this, this bad thing happened, or people were making wrong decisions, etc., right? So there's always a human in the loop to check what's happening. And that's one thing that's today, but also we need to build the models that are explainable, because a lot of the deep neural networks, imagine billions, have even touched trillions of parameters. How can you explain what the neural network is recommending, right? So
Yes.
you need to, that's a huge area of research called responsible AI and explainable AI. So that has to keep up with the growth in AI, right? So if you look at Google and these big researchers and big companies, they are also investing, and academicians are investing in this space.
All right.
Okay.
Thank you. Thank you.
So if there are no further questions, thank you, ma'am.
Thank you. Thanks. It was my privilege and honor to be here.
We look
I
forward to you
witnessed
again.
Yeah. Thank you. Bye-bye.
Thank you. Bye. Bye. So our next session, for the next session, we have the speaker from Reliance Jio Mumbai. His name is Mr. Anish Mishra, and he will be, the topic is telecom service providers perspective. All of us know Jio is the largest operator, telecom service provider in India. So just a brief intro of Mr. Anish. So he is an experienced and passionate engineering leader working with software and telecom industry for more than 20 years. Mostly focused in building, architecting new product ideas for large scale and high performance system. So over to you, Mr. Anish.
Thank you, Srinath, and thank you for this opportunity. So let me put my PPT first. Is my presentation visible?
Yes, yes, yes.
I'll put into presentation mode. So basically, I'll try to speak more from use case perspective and what as a telecom operator. Okay, like in the initial inauguration discussion, where Honorable Secretary tried to speak. Okay, what is our customer perspective, or how we are efficiently managing the OPEX and CAPEX so that we can offer the services on the lower cost. Okay, so how we are leveraging AI as part of in this space, and what kind of optimization we can do. Okay, so all these things actually I'm going to cover as part of this. So these are the key things actually which I'm going to discuss as part of next 25 minutes. So basically, what are the use cases in telecom, and for the use cases actually, what are the key steps actually we need to take as part of putting these steps actually, so that we can leverage that AI and ML in telecom space more and more. And then I'm going to talk about the use cases, especially with respect to network planning and optimization and engineering. Like suppose the congestion is happening. Okay, so how we can avoid that kind of congestion, or maybe how we can improve the overall customer experience better. Okay, so that then I'm going to speak about, like, there are a lot of anomalies which keep happening onto the network. Okay, like as part of our India, actually there are a lot of fiber cut happen. Okay, or maybe there are power outages which is happening as part of the rural network and all. So how effectively we can have a kind of predictive way to find out, okay, this kind of anomaly can happen, and what preventive action we can take, or how we can optimize overall time to optimize our overall maintenance period. Then there are a lot of as part of our network. Okay, suppose like IPL is happening. Okay, so what is the impact in my network of that particular IPL? Or suppose there are elections which is happening in 4-5 states, right? So how that is going to impact my network as part of that election, or suppose this is an event actually we are doing. Okay. So how is that event having any impact on my network? Okay. So how we can find out what kind of special event which is happening is affecting our network. Okay. Whether that particular thing is pushing us for a network upgrade or not, or should I should not do it because this is a special event which is happening and this will over in kind of a 1 hour or 2 hour. So my network spike will be down. Then, so these are the various use cases actually we'll be speaking it about. And then what is the challenge as a telecom operator? What are the challenges we have and what are the key technology transition which is happening in the network, okay, to overcome the challenges. Okay, so these are the topics actually which I'm going to cover. So if you see actually from geo point of view, we are working on the network side. We are leveraging AI in the network side. We are leveraging AI in the customer side. We are leveraging AI in the 5G side also. Okay, but mostly I'm going to focus on the network side as on today. I think in the first speaker actually he tried to cover some of the portion on the 5G side, which Ericsson is already doing. And on the network side also, I think in the previous discussion with the previous speaker, actually she tried to cover some of the optimization which is happening as part of the chipset and all. Okay, where they are trying to introduce the AI embedded as part of the chipset itself. Okay, so that kind of evolution which is happening to manage more network efficiently, and customer experience. That's a key actually from an operator point of view. Okay, so for us actually, suppose you are making a successful call, you are making a failed call, you are making a successful browsing, you are making a failed browsing. Okay, so all data points are important, and believe we are working in each and every data point as an organization. We know, okay, this is important and what kind of optimization is required, okay, from customer point of view. So at the end, actually, the key area is like, okay, customer experience is the most important portion. And with the customer experience, we are now we are looping back with how we can have this optimized network which can be operated, okay, with respect to our OPEX and CAPEX. So so that is how this customer experience is looped. And with respect to 5G, actually, the key focus is how we can bring more and more use cases, okay, which are system-driven use cases as part of 5G. So I'll try to cover mostly on the network side as part of this discussion. Like we spoke, there are various algorithms and various algorithms and various tools are available as part of various open sources and all. Okay, but what are the key steps actually which we start to believe, and what is the key steps actually we need to think of to build a ML base for any of the use case actually, whatever I mentioned in the previous slide, any of the use case, what are the key things which is required. See, at the end, actually, there are billions of data which is lying. Okay, so it is for us, it is easy to say, okay, there are the data sets, but the data sets are kind of billions. So at the end, actually, the person who understands the data, that means the domain expert, which is the key for if you are trying to transform into ML. Okay, so that's one of the key skill set which is required as part of the overall evolution. So that means the domain expert. So mathematics, because normally in ML actually we treat 0, 1, 0, 1, 0, 1. Okay, so that kind of algorithms are there. Okay, so as part of that algorithms, actually, I think maths, if you have a good maths, okay, so that will help you to understand all the algorithms and behaviors, and then accordingly do it. I think this slide is not visible. Okay, the cross one actually is a programmer. Do you need to be a programmer for having building a ML or working on ML use case actually? So you do not need to have a programmer to build a kind of a ML use case, okay? Because there are a lot of algorithms, a lot of analytics tools which are available. You just need to know how to use them. That's all. So especially you don't have to be a programmer. Now, with respect to data readiness, okay, so why we are saying domain expert, okay, because the data readiness is one of the key thing which you do, okay. So any use case is directly you have to map with your data readiness, what kind of data are required for that particular use case, because you have a billions of records, okay, but what are the records actually which are going to be interested as part of your particular use case you are trying to solve. Then the algorithm selection. So there are various algorithms. I'll show into the next slide actually. So there are various algorithms, open source algorithms, which are there. Okay, so which algorithm is going to be kind of suited for me? Okay, so that's something you have to take care of. And then what are the parameters you need to tune, okay, so that your outcomes are matching with whatever you've started to building your work. Okay. Yeah, so I'll move to next actually. So these are the various data libraries and open source which are available for you. Okay, so in popular, I have captured few of them actually. So if you see from data library point of view, there are NumPy, SymPy, NLTK, okay, Panda, SciPy. So all these are data libraries which are available as part of open source. You can use depending on your various use cases and data structures you are going to manage. Then if you talk about various ML libraries, okay, so which you can use it, like TensorFlow is one of the popular one. You can use PyTorch also, like for some of the cases, actually, we are using this also. For like you can SEG, you can use AML, you can use, okay, so then Watson or Core ML. So any of them actually, depending on various use cases, actually, you can use. And at the end, actually, in the right side, on the right side, actually, I have, let me put a pointer also. On the right side, I have tried to explain you, okay, how, so if you try to match with the previous steps, okay, so basically what you have to do is you have to use the data sets, okay, so you have to put into data set into some kind of a big data, and then you train that data, then you build various models, and then you start running your model for whatever outcome actually you're looking for. So these are the key enablers actually. Okay, so I just wanted to bring you, okay, these are the key enablers actually when if you want to start any project in this particular area. So these are the various building blocks, you can use it. I'll talk now. I'll move to some of the use cases actually. Okay, so how and what we're doing as part of Geo. So if you see here, what we do normally, okay, earlier what you used to do, okay, so earlier why we used to monitor the trend of any pipe, okay, in the transport especially, we used to monitor, okay, how my utilization is growing on, okay, so on accordingly, actually, suppose that utilization is more than 70%, I'll start moving the material and sending it to various location, and then we'll upgrade it. But what we have done now, but what we have to do is we have to start that preparation from when you are on 60% or 70% of your utilization, then you have to start this preparation, because there are a lot of manual work is required where you have to dispatch the material and then you have to plan the upgrade and everything. Okay, so that was the traditional process actually. Now what we did here actually, we have used some of the algorithms, and now what we're doing is we are trying to predict the utilization on each and every link actually as part of our this. And with the ML, actually, we are able to predict when this is going to hit. Now, what I'm doing is, okay, I know, okay, that I can have a material movement in advance. There is no problem because I'm able to have a prediction almost like 30 days before. Actually, I'm able to accurately predict, okay, which are my link actually can be upgraded. So suppose now I can delay my entire upgrade process. So I can wait, okay, till 80% actually I'll wait. And once 80% it reaches, okay, then I'm going to upgrade my network. So overall, what I'm doing is I'm delaying the overall capex of the organization, okay, so that we can offer the better services and we are not investing the equipments on the where it is not necessary. So this is one of the use cases actually. Even we are able to predict how many links are going to be part of this, which category, like 50 links are going to be part of 70 to 80% category, or 90 links are going to be part of like your critical category. So all those categories you can identify. Even for a special event, actually, okay, so we are able to identify, okay, suppose IPL is happening, okay, so what is impacting my, so if some of the interesting trend, maybe I can share it with you guys. Suppose a match is happening between Mumbai Indians and Delhi. So we see that, okay, the spike is happening in a few clusters. Suppose a match is happening between Chennai and Mumbai Indians. Okay, so then again we'll see, okay, the spike is happening in certain cluster. Okay, so these are some very insightful and interesting facts actually we are able to gather. And all this, so earlier in traditional process, actually, we are not using these insights. Now we use all this insight, okay, whether they are eligible or this is something temporary. Okay, we have to just ignore and all. So this is a very interesting use case where we are able to save a lot of capex as part of our this. Now, another use case actually. So what we do is normally we are trying to, so in ML actually we are using clustering methods. Okay, so in clustering method, what we're trying to do is we are trying to find out the anomalies. Okay, that means if you're seeing, okay, specific links in transport, actually, if you're able to see, okay, specific link in transport is giving me trouble again and again, I think more than 10 times. Okay, so that means more of we treat as a kind of unhealthy ring, and there's something need to be done over there. Okay, that something is something which will like we have to analyze the further data and then accordingly we'll able to take. But at least what we are able to do is we are able to identify the clear actionable with respect to what need to be done. Okay, and where we need to focus. Okay, because you cannot focus the entire spectrum. So what you have to focus, you have to focus on the problematic areas. Okay, so now here we are able to identify what is severely unhealthy link, what is moderate and unhealthy links, or what is actually healthy links. Okay, so we don't have to focus on X and Y. What we have to focus on A and B. So earlier what we used to do is like we used to have a more of a reactive basis. Now this is more of a proactive basis. We are able to identify these trends and we are able to do actions. So if you talk from ML point of view, so we are using recurrent neural networks and then clustering techniques to derive this kind of use cases actually. Another I was speaking about like fault prediction. So if you see here, I think this is a basically kind of almost a near real time the changes which is happening as part of your transport network. We are able to identify, okay, what kind of changes is happening as part of this, and using a recurrent neural network actually. Okay, so what we are able to do, we are able to predict some level of fault. Okay, depending on various data sets. So, and then accordingly, what we are doing, we are activating the field actions in advance so that the overall fault time can be reduced. Okay, so this is one of the use case actually which we have developed. And I think we have initially we speak about this capex saving and operational efficiency also. So what we have done is now we have clubbed the multiple technologies. We have clubbed your ML, we have clubbed your AI, then we have clubbed your robotics. Okay. So here what we're doing, suppose I'm able to get some fault. Okay. So what happens in the field? The people will go in the field actually. Earlier they used to go in the field and suppose they have to change something or something need to be fixed. Okay. So they need to have one person sitting in the NOC. Okay. He'll call him and then he'll try to fix it. Okay. And he'll talk to him and then he'll make some changes and he'll fix it. Okay. So now what we are doing. Okay, so what we have done is now we have built this entire framework. Okay, so here actually I don't need one-to-one mapping. Okay, that means every field engineer he do not require a kind of a call center kind of concept where he is waiting for his time to get it fixed. So what we have done is we have created this entire framework where he's talking to bot, and bot is able to take care of the L3 level of access. That means he's able to make the changes. He will able to tell you also now whether on the other side there is a fiber cut or not. If the fiber cut is there, please do not make any changes as part of this. Okay, it will able to tell, okay, where you are eligible to make this change or not. If you are eligible, then only it is going to change. Okay, so all the governing action is able to take care using bot center. And in case any exception, okay, so in case that bot is not able to solve something, okay, so then again we are leveraging ML. Okay, so if bot is not able to solve, it is going to knock engineer, but there again we are leveraging ML and we are feeding back again to the bot center. So next time that same problem is coming up with someone else, okay, the bot center is able to take care of. With this actually, like suppose we are in a process of like 5G upgrade, network upgrade. Okay. So earlier we used to like do, suppose I'll give you some random number. I won't able to give the exact number. Suppose we are able to do like 50 earlier in a day. Actually, on the 50 places I can go and upgrade my cell site equipments. Okay. But today actually I can just do it 500 or 1000. I don't have any constraint with respect to this entire manpower over here. Okay, there is no constraint. Whatever I can do in the field in 24 hours is doable. So there is no constraint. Absolutely, there is no constraint from us with respect to upgrade. That's why we are upgrading one of the fastest way to upgrade for our 5G readiness and all. Now, let me speak more about this. What is the key challenges? Okay, as part of operator. Okay. So if you see as on the devices, actually, there are more than 126K different data types. That means you get syslog, you get alarms, you get performance data. Okay, so there are you get telemetry. Okay, so there are like tons of data which is available as part of individual device. So as Jio as an organization, we have more than 600K devices or IP devices, I'll say. There are many more actually, but 600K, you can say network IP devices are there. So if you multiply 600K by with 126K, okay, so you can understand the records actually which we are going to get as part of overall this. Now another challenge is like, okay, these are the device specific information which is being sent. But suppose what we are doing, we are giving you service. Okay, so in service actually this is not one device which is playing a role. There are multiple devices which play a role. Okay, so that means your individual specific device counter need to be mapped with your various services you are offering. That service counters actually. So that need to be. So whenever any like vendors actually they are building these boxes, they are building these boxes specific to serve on the device level, and as an operator we are serving on the network level. So how we can correlate this device specific counter with the network actually, that's one of the key challenges we have. Okay, then what we can make a change, okay, which like any event which is happening, suppose something is getting down, okay, so as part of that, yeah, that the counter should be coming as part of your event driven. Okay, so so for this also what we're doing is we as part of collaboration we are working with various vendors, like in a previous discussion like Intel was saying, okay, so as part of chip itself actually they are enabling AI. So similarly what we're doing, we are working with our network vendors where we are trying to like 126K counter where we are working to get it less than 100 interesting counters for us. Okay, so that means what will happen is the AI will be enabled as part of the router itself. That means any like for every event actually it used to send one counter. Now what it will do is it will correlate and send that counter. So overall what you do, you are going to reduce the number of data points, and then and that will be mapped with along with the services. So we are working along with the various vendors, and I think this we are in a good shape in this particular area. This is a kind of a change which is happening as part of overall collaboration with operator and between equipment providers and other places we are having. So that's all from my side actually. I think so this is all from my side. Srinivasji.
Thank you, Anish. Thank you for sharing the perspective from Reliance Jio. It was a wonderful presentation, and now we'll quickly go to the next speaker. The next speaker is Mr. Saurabh Basu. He's from CDoT. So just a quick introduction of Saurabh Basu. So he's a group in charge of CDoT, Delhi Premier Telecom Research Center of Government of India. His team is presently handling the implementation of CAP project for disaster management at pan-India level, Trusted Telecom Platform, MTCTE platform. He is having around 12 years hands-on experience as solution architect and cyber security specialist in various geo-intelligence software solutions, security solution, M2M systems. He is one of the key persons of ITU focus group on AI for natural disaster management and telecom standardization in India for both 1M, 2M and common alerting protocol. So he has published over 20 international research papers and journals, along with 3 international and Indian patents. So his present area of interest is AI, ML, telecom security and disaster management. Let me also share with you that the CDoT paper on this CAP has been also shortlisted among, along with other papers. So we are very proud of CDoT. So over to you, Mr. Siddharth Basu. Sorry, Saurabh Basu.
Yeah, thank you, sir. Thank you for giving me this opportunity to present the this webinar, how CDoT is doing in this AI domain. So let me share my screen. Yeah, I'm putting on the presentation mode. Yeah, is it visible?
Yes, it is visible,
Okay.
Saurabh.
Okay. So, good afternoon, everybody. So, thanks. So, thanks for giving me this opportunity. So, in today's webinar, I am going to talk about what CDoT is doing in the AI domain, specifically in field of disaster management and telecom security. So CDoT is also doing in domain of various domain of the telecom for using AI, but specifically in the today's session, I am going to talk about these two specific things which my team is doing. So in today's presentation, I'm going to highlight what is the paradigm shift has been observed in the ICT sector. What is the current scenarios and challenges we have observed in the telecom sector on adoption of the 5G and beyond? How the artificial intelligence going to be the visionaries of the telecom sector? Then I will come to the specific topic, how AI is effective for communication in terms of disaster management and emergency telecommunication. AI can be play a very important role in telecom security and trust assurance of the telecom products. So, yeah. So in present date, telecom sectors are facing increasing demands for increasing demands of higher quality of service, low latency, and better customers experience. And in last few decades, telecom service providers have gathered vast amount of data in terms of service usage, in terms of customer profile, in terms of geolocation, in terms of network devices. So this using this data, using AI, ML, and this analytics, we can make a good way forward to make our ecosystem more efficient and more useful. So let us focus on what are the current challenge and scenarios we are facing in the telecom sector and how AI going to play a crucial role in this thing, in this changing scenarios. So first, we need to understand what is the in the growing mobile ecosystem handling the large customer handling the huge customer demand in terms of the higher bandwidth, low latency. Okay, homogeneous amount of data is need to be to combat the network congestion and overload. Moreover to that, resiliency, and there is a need. So we are talking about the connected cars, smart healthcare system. So they need a business critical connectivity. Along with that, so there's another paradigm shift we have been observed in the last few years post pandemic. So everybody is working from home. So from working from home or working from anywhere, anytime demands a um, homogeneous network infrastructure and connectivity across any location. Along with that, we also observe there is a huge increase in cyber attack surface in the current scenarios. So, to address this kind of security challenges, CDoT is doing some things. So now, what are the main impact or the main impact areas where AI can help the telecom sector in telecommunication? We can say that there are the major sectors of the network security, in network optimization, network planning, predictive maintenance, for better communication during disasters, for better modeling and for projecting and forecasting, as well as virtual assistance. So these are the broad areas where AI can help and its impact and help with the telecom sector and gain the better outcome. So through AI, as Honorable Secretary Sir has guided, AI can be add as a layer. So agnostic to the any domain, any specific area. So AI can be added as a layer and can be useful in the any perspective. So in terms of quality assurance, in terms of security assurance, in terms of resource management, and in terms of efficacy improvement. So the AI-enabled innovation areas is mainly smart cities, healthcare, public safety and infrastructures, self-driven car, augmented reality, virtual reality. And along with that, our Honorable Prime Minister has come up with a vision for national resiliency against disasters. So he have been defined a 10-point agendas, and here in the 10-point agenda, is point number 5 and 7, he have been highlighted how we can use the ICT infrastructures in a better manner to make our country disaster resilient. So along with that, we want to highlight CDoT is presently working in the AI and the security domain and the trust assurance domain. So next, come to the actual topic. So I like to, as Srivas sir already told, CDoT is implementing common alerting protocol compliant integrated alert system at pan-India level. So what this system? So before I coming to the how AI is going to play a big role in this, so let me explain a few things about the what is CAP system is that. So common alerting protocol is a ITU standard. So this will integrate all the systems. All the system means there are different alert generating agencies. There are different kind of alerts: meteorological alerts, flood alerts, tsunami alert, fire alert, some terrorist, law and order related alerts, agriculture related alerts, healthcare related alerts. Okay, and which need to be disseminated among the public in geo-targeted manner. Like suppose there will be a vaccination camp is going to held in your society, and I'm located at the Noida and Noida sector, specifically in Apnar sector, let's say XYZ. But and the camp is only meant for the sector XYZ. But if I send the message of set up of the camp across the Noida, so it won't be going to serve the purpose. So people may lose interest because they are started receiving unnecessary information. So for geo-targeted warning, we need to integrate different kind of dissemination media so that multiple mode, if you able to reach the users over the multiple mode and the multiple media, so the usefulness of this alert and the efficacy of the alert will be more increased over. So in this regard, we are integrating different medias like SMS, cell broadcast, social medias, Facebook, Google, WhatsApp, televisions, radio, pop-up internet, pop-up based internet, the pop-up on internets, OBD calls, voice calls, signage, railway systems, sirens, coastal sirens. So various mode we are integrating. So this system is presently being implemented. But my present topic is mainly focused on the after implementing these challenges, this early warning system. So we have found some drawbacks or some not drawbacks, some gaps is there. So using AI, that gap can be resolved. Like if you are giving warning to the citizens, but citizens is not responding to the warning due to many reasons. Means I am giving warning to Odisha and I am giving warning giving the warning message in English. So rural public is not going to understand this message very clearly. And not only the language, if you are giving the technical information. So technical information means I'm going to give an alert for cyclone and I'm going to say this cyclone is going to hit Odisha with this much of this kilometer and the present location is this much or this is that long. So this information is not going to serve the purpose to reach out to the common citizens. So we need to suggest them with a proper instruction and action. They need to take care. So though you might start feeling that how this is related to disaster. Sorry, how it is related to telecom. But we need to understand that when there is a disaster, the network congestion arises. The telecom, the normal telecom infrastructure is not working as it working in the normal period. So there is the capacity is of the network infrastructure is came down due to the preparedness and due to the prevention measure. But if the people got panicked, so they used to start calling. So it's going to create the congestion. But if we are if you address the people in a right manner in the right way, so it will help us to utilize the available infrastructure in a better manner to make our to utilize the system in a better way. Now, as I told, we are going to send warning in various mode over radio, over WhatsApp. Now we have to address. Suppose in Delhi, who are the tech-savvy person is sitting in the office and doing just like attending webinars or attending meetings or doing office works. So every time we're not very keen to see the messages. So so the message used to come and it will keep there. So whenever we got free time, we used to read the messages. But the thing is that But if we get any notification in our mobile, in from any mobile app or any WhatsApp, so the tech savvy person, the person and the urban of the urban sectors are more, those are more tech savvy, are more interested in the interested in receiving message in the new technologies like WhatsApp, new social media things like Facebook. So if instead of SMS, and if I'm sending the TV, broadcasting the message, disseminating the message over television, so that won't be very suitable for the urban people. However, the same television and the radio and the SMS will be more suitable for the people sitting in for the rural areas, for the coastal belts, for the other areas. So we need to identify how efficiently we can use this mode, so that for the sending this message, disseminate the disaster message, we should not congest the existing ICT infrastructures. So we should select the right targeted area, and select the right communication media, so that utilization of each media and audience reach can be ensured. And as per UNDRR work program data, so it is well evident that if we are able to give that dissemination message in more targeted manner, so and with more precisely, the message content should be more precisely, so that will be more efficient and more understandable by the common citizen. And that's why we can prevent we can say more human life and property from loss due to disasters. Now, in this regard, what CDoT has done so far, so just like along with the natural disaster, there are other disasters. So natural disaster, just like heavy rain. So heavy rain alert is being issued by the IMD. Okay, but the thing is that some shop in Nehru Place got fired, set to fire. So there is fire outbreak. So, but this message is not going to give by any of the body, but people sitting nearby the residing nearby the Nehru Place used to tweet, used to give in post in the social media, or some of the news media covering this thing. So the person who are going to Nehru Place or residing nearby area, by filtering out this message, we can trigger a warning to the people who are going to visit Nehru Place, or who are residing nearby area. So we can track and monitor from social media. We can filter out this thing, so that, and this can also help the disaster manager and the fire brigade. So if there is a fire related event, we can quickly trigger. So no person need not to call to the fire department to send the fire extinguisher or this something to make the thing in control. Similarly, there is some water logging. So there is a huge rain since the whole night, and the morning it will be fine. There is a huge water logging. So people when came to some of the people when going for morning walk, they came to came in notice there is some water logging. So they may report it through over any media, maybe through social media, maybe through any post. So utilizing this mechanism, so by creating this mechanism to identify this mechanism, we can easily trigger a warning, and we can make into an actionable item for the disaster manager and the rescue team, or the NDRF team, or the SDRF team, or the police department, so that the loss due to disaster can be optimized. Next, so now I'm giving to a bigger picture of this idea. So we came up with a concept called AI-enabled decision support system for disaster managers. So disaster managers, so in disaster managers, not only the disaster management authority, disaster manager, police department also a disaster manager, hospital also a disaster managers, so NDRF team also a disaster managers, fire department is also treated as a disaster managers, or the called first responders. Now, so we can get the data from crowdsourcing. So people feed the data from different media, or from a mobile app, from Twitter, from Google, from Facebook. So we can automatically, AI-based engine will going to filter out this data, and it will help. So filter, so along with this data, if you are going to collect this crowdsourced data, we need to think along with the actual data, there may be some unwanted data and unwanted information also be passed to the managers. So we need to filter out the data. So only relevant and necessary information that need to be addressed. Just like during COVID time, everybody is tweeting, I need this thing, the bed is not available. But some of the messages very need to action very immediate basis, and some of the suggestions, some of the is criticizing, and some of is showing their discomfort against the system. But whatever the actions people are demanding from the government and demanding from the authority, if we're going to create out of 1,000 messages, there are 2-3 messages will be there which is need immediate action. So if we able to filter out this 2-3 Twitter post, so that will be help the concerned authority to take necessary action at the earliest, so that the actual help can be facilitated to the citizens. Next, as I'm telling earlier, if I'm going to give a message, just like cyclone Never at the right bottom corner, I have the message showing the cyclone Never with wind speed 120 km/h is expected to make landfall near Puducherry on 25th November at 11:30 am. Please stay indoors. So we need to understand, does the message is going to give a clear message to the citizens? So the person staying in the concrete house, they can stay indoors, but those who are residing in the kacha house, so we need to instruct them to please evacuate your evacuate and stay sheltered in the cyclone shelters. So this kind of message content analysis also we need to be done based upon language, based upon content, based upon frequency, based upon dissemination medium. Along with that, we need to identify the alert scope. So we need to predict the alert scope. So suppose in coastal belts, we are sending a message over the WhatsApp or message over the any internet media, but the internet user is very less in this area. So we should, based upon the media, so which media we should select. So predict the so we need to predict that based upon the targeted recipient and the mobile subscriber counter based in that area selected, its population, its demography, and its written model. Along with that, we need to take ground feedback. So whatever the message is sending, is it relevant to them? Is it that they are satisfied? So based upon that, the cross feedback will help us to mature our AI based system, and that it will make the going to easy the life of the disaster manager to take a proper decision in the right time. Now, along with that, predictive analysis. So predictive analysis means, so if I'm going to select, so suppose there is a warning which is going to hit in the central Delhi. So if I'm going to select as whole central Delhi and send the SMS, the SMS is that there is going to be heavy rain. The alert is there for heavy rain alert, very heavy rain. But if I select the area of central Delhi, there will be crores of telecom subscriber subscriber will be there. So unnecessarily we're going to overload the SMS gateway, SMS centers of the telecom operators. But if we do analysis, predictive analysis, if we're going to identify what are the low-lying areas, what are these going to be impacted actually. So heavy rain is a very common phenomenon. So based upon that, we need to identify the how predictive. We need to do the predictive analysis. Based upon that, we need to predict how this data, how this warning going to be forecasted in effective manner. How to need to work, how we can warn the people in a very effective manner. So in this regard, we need made a critical analysis on this crisis analytics analytics things. In the diagram, we are showing that we have categories in the 5 part. So what are the challenges? So challenges, what is the volume, variety, veracity, validity, velocity, values, and the volunteers and the privacy. What are the data source? So data source can be the data exhaust, online activity, it's a sensor data, it's a small data, it's a public data, it's a crowdsourced data. So these are the factors. Based upon this, we can make a predictive analysis. Next thing is the enabling technologies. So by which means we are going to reach? By mobile phones, by internet, or any AI/ML based predictive models. It shows that crowdsource data saying that what is the geographic information is having with it, virtual analysis, and this is open data. Along with that, we need to also focus on the future directions. So what is the reliability of this data? If I'm going to predict, going to disseminate some information in the citizens, so we need to understand how much reliable in the information. So in frequent manner, if I have to give some message which are not reliable, suppose I'm giving a warning, there may be a severe lightning within half an hour. Please stay indoor. And there is no lightning at all. And this kind of event take place repeatedly. So people will lose interest in believing these kind of things. So we'll keep utilizing the telecom infra for sending SMS, ICT infrastructure for sending, for television media for sending broadcast, radio for broadcasting, but people won't react on the message they are receiving in their from their various mode. So we also need to understand disaster tolerance, just like, so if there is an earthquake going to happen in the open area, say in a forest area, so we need not to we need to take some precautions, but we need not to worry, we need not to disseminate the message. But if an earthquake going to happen and we're going to identify this, and there is, and the targeted area is going is full of high-rise building, so it need to be act very immediately. So these kind of things we need to address, to use this infrastructure, to use the ICT infrastructure in a better manner to address disaster communications. Moreover to that, just like emergency calls, AI chatbot kind of thing, so that automated assistance can be provided. So every time they are not tech savvy, so no one going to open the mobile and no one going to call. So number of the call center executive will be very limited. But if we put some AI chatbot kind of thing along integrated with the systems, and based upon the automatic trigger action will be suggested what they had to do. So these kind of things will help us to facilitate the emergency calls. As I already told, the social media analysis. So in this regard, we have been already made some contribution to ITU focus group for AI for natural disaster management in use case of AI-enabled citizen-centric decision support system for disaster managers. Next, we have made another work in this domain also. So that is regarding the early warning for glacial lake outburst, GLOF. So 1/3 of Uttarakhand Tehsil is vulnerable to massive glacier floods. In last year also, Uttarakhand has experienced one of such flood. Similarly, has been also observed in the Sikkim. So, but there is no traditional mechanism for identifying, and because it is giving a very less lead time to act upon on identification on the when the actual outburst is took place. So we need to do a predictive and forecasting based. We need to work on the forecasting and predictive based mechanism. So what we need to do, we have made a master repository of the glacial lakes and via multiple satellite images. So we are working with the ISRO to getting up the frequent image satellite image and to identify what are the glacial lakes. Based upon that, we have with help of the Uttarakhand State Disaster Management Authority, we are trying to identify the risk-prone inventory. So this data will be help us the decision making in the actual time. Now, based upon the glacial lake satellite image, we have do the image processing, image segmentation into land and water, and most of the thing is the challenge is into object classification, because the image is not very clear. We cannot identify, because the glacial lake will be covered with the muddy footfall. So that's why it's not very clear to identify each and individual glacial lakes. But we are working on that. So, and hopefully we'll go. We are working also IIT Roorkee to get a good result out of it. So that using this, we are going to identify if there is a crack in the glacial lake. So based upon that, we are also going to take crowdsourced data. So based upon this, our object object classifying the risk-prone areas and the crowdsourced data, these three will help us to monitor the lakes and trigger the early warning right in time. We have also make a contribution in ITUT focus group for this also, a systematic approach towards AI-enabled monitoring and early warning for glacial lake outburst. Hello. Am I audible?
Yes, go ahead.
Okay. So, so now along with that, there are other things I also want to highlight over here, that linguistic annotation solutions. So using this methodology, we are going to say there are a number of solutions available for natural language processing, the translation, the conversation, for speech synthesis. But in India, there are various different languages used to be spoken by the citizens of India. But and every 100 in every 100 kilometer, the way of speaking is same language. Just like in Delhi, we used to speak Hindi in a manner. It's not same to as we speak Hindi in Bihar. So that speech synthesis is a very much crucial thing to understand this risk, and this will going to facilitate our customer supports executive or the emergency call centers, or maybe in the telecom call centers. So chatbot should be enabled. The bot center will be enabled with this evolved speech synthesis solutions, linguistic annotation solutions, so that the address the customer is calls going to land in the call center will be addressed in the right manner, in the right way. Now I'm coming to the another aspects of another area where CDoT is working. So AI for security. Now, as I am telling, we are all working for the post-pandemic. There is a situation we all need to work securely from in a home or from anywhere. So suppose I'm working from home and I bring my own devices, and somehow my devices got compromised, and I'm responsible for configuring a node which will be a crucial node of 5G. So my whole network is going to be in risk. Though there is a number of security parameters and authentication and authorization mechanism in place, but there should be unified methodology to identify security threat well in time, and real-time visibility and analysis should be there. Along with that, we should optimize the response model so that fraud detection to prevent the user data as well as the network infrastructure data can be addressed in proper manner. So how the mistrust is happening in the current ICT environment. So first is the privacy infringement. So whatever the customer, what is the mobile use, our customer of the telecom infrastructure sharing data, their data going to be their privacy is going to infringed, and there is security breaches happen in our telecom infra. So if you are going to ensure the privacy of the information and the security of the telecom infra is going to be revolution, is essential for this upcoming days. So in this regard, what we have done, so just like you must be all aware that we have a vulnerability called Log4j is coming in the month of December, and it affected various systems across the world. But it's a 0-day attack, so no one is aware of the thing. Challenge is that the security is not a single time job. And if I'm giving a software, today I'm giving a software, a secure software, I have ensured I have updated and I have followed all security guidelines and all the security things in our software. But down the line, after 5 months, 6 months, so its vulnerability factor going to be high, because day by day the bad actors is going to find out the loopholes in the systems. Log4j is one of such cases. So to prevent this kind of 0-day attack, so we need to create a mechanism called disaster cyber early warning system. So different this log4j vulnerability. So if any organization is having some challenges or faces, they are posted in the internet, and this data is the information is available in form of feed, in form of vulnerability basis, and other websites. So if we put an engine, will automatically analyze this thing, and it will update your CM system as well as your network administrator, so that automatic update can be happened at the right time and the very quickly manner, so that the security warning can be addressed at the earliest. Similarly, what is the difference between, so as I told you, there is already a system is in place in the systems. So most of them are just like antivirus. So what is the difference between legacy antivirus and the AI-based security? So most of the legacy security solutions are based upon the signature based. So whatever the inventory, whatever the threat database they are having and they are updating. So based upon this threat database, they are preventing their systems. So it's very, so this sandboxing kind of systems are very slow to react. Whereas the AI-based security, it's work upon the predictive analysis model, behavioral detection. So it will help us to mitigate the exploitation at earliest at the quick as possible. So for beating 0-day, sanitize your file systems and protect for your system from advanced persistent threats and malicious content. AI-based CDoT is also coming up with this cyber early warning system, which will going to benefit the whole telecom infra. Now, another concept is the trust assurance. So every software is built with some sub-software, subsystem.
Excuse me, Saurabh. Saurabh Basu. Sorry to interrupt you. Actually, we have some time constraint, and then we have another guest speaker also waiting. So, may I request you to conclude it early?
This is the last slide, sir.
Yeah. Okay. Okay. Thanks.
Okay. So, trust assurance system is some like that. Every system has built upon some subsystems. So, if you are developing some softwares, so we are not developing each and everything. We are using some sub-softwares also. So if we come up with the software bombs, and if you keep monitoring on the security vulnerabilities in this individual subsystems, so it will, and using DLT kind of thing, digital ledger technology, blockchain kind of thing, so it will help us to, through data mining, it will help us to evaluate the threat and to mitigate the threat at the earliest. So these are the three things we are presently doing. So AI for trust assurance of the telecom product, AI security for disaster along with the cyber early warning system, for predictive forecasting, and the AI-based decision support system. So that is as of now, sir. Over to you, sir.
Thank you. And wonderful presentation. So now we have, sorry, actually we are lagging behind time, and we have just one speaker, that is the last speaker, and officers and friends, we have heard the inaugural secretary today. He has emphasized so our next speaker is from a startup company called COIGN based in Hyderabad. So his name is Mr. Srinath Reddy. So just an introduction of Srinath Reddy. So he is working as director and head technical in COIGN Consultants Private Limited. He is in charge of product development, client acquisition, customer relations, team building, and exploring overseas education opportunities. He is working member of Indian AI stack developed by DOT. As I said in my talk initially, I said there is this Indian AI stack being developed. So the committee has been formed by DOT. So he is also a working member in that. He has been co-opted by the committee. So over to you, Mr. Srinath.
Thank you, sir. Thank you very much. I've just shared my screen. Is that visible to everyone, sir?
Yeah.
Great.
Please go ahead.
Yeah, somehow my cam is not working properly, so I prefer to have the slideshow. All right. Thanks for the speakers who are all there so far. They made my job very easy because they spoke about a lot of infrastructure requirements on the software and hardware side, and the toolkits, and also the libraries and packages that are required for the AI as a whole in different use cases. And most of the speakers have covered a lot of use cases in the telecom domain. And specifically today, I'm going to talk about present a case, simple use case, which we have been working on a proof of concept kind of thing for a devotee, which will be which is under still early stages, I say. That is like using the face identification in CAF CAF. Which is like CAFE's customer application form. Basically, I'll try to explain the problem statement in simple words so that we can understand the use of AI in simplifying the this problem statement and creating a value around that. For in India, as far as our knowledge, like every individual can have 9 SIM cards on his individual name for a single person. I hope the number still holds good. And being a country which has almost like 1.4 billion registered mobile SIMs across the country, identifying which person has how many SIMs on his name is very, very important to avoid security vulnerabilities and also misuse of the SIMs from the rural places majorly. In many places in the rural India, what happens is, just a second, just a second. Just a second. Yeah, identifying the this kind of misuse of the SIMs, okay, is very important in rural areas. So just imagine a case where a village, in a village, a person wants to buy or take new SIM card, and he enters the retail store. The moment he enters the retail store to purchase the new SIM card, and imagine the retail store owner have a small smartphone, and he takes a picture of the person who is walking in. And the moment he takes the picture of the person who is walking in, if the app can say that to the user, saying that in his local language, regional language, saying that, okay, on your name so far X number of SIM cards are registered, okay, and this is the new SIM card now you are going to apply. So that alerts him whether he is the real owner of the SIM cards or not. So this is the problem statement we are actually working on, where we have to use face recognition algorithm in the real time, and also we have to understand how many already registered SIM cards are there on his name using the previous CAF data. So hope I'm clear with this problem statement to everyone. Is the problem statement clear?
Yes, go ahead.
So then how are we approaching this? So we have taken a couple of samples of CAF from the department, and the CAF is generally in this format, where once it is filled, it comes in this format. Okay, this is by Geo, where you have the picture on the top right corner of the customer, and the other details of the customer is filled in the form automatically to the application these days. Okay, once we get this kind of PDFs to the application side to a secure location in the server, then one of our APIs actually extract those images and saves them in another secure location, and while extracting it, it also tags it to the user unique identification.
Mr. Reddy,
yeah.
Please use slide this thing, play, so that this slide becomes bigger.
Clear?
No.
Hello.
Use the slideshow so that the slide becomes bigger. Yeah, it's okay.
It is.
Good.
Yeah, it is. Yeah. So the moment, so this extracts the images and also saves with the unique number which is given to the every calf. Okay. Later point of time, these are processed in the background with our image face recognition algorithms. We're using deep face. So we are using deep face from the Facebook, which is a open API, and we're happy to experiment with any other APIs which are available, which are open source, so that the basic final outcome should be improving the efficiency with the lesser number of data points. That's what we are trying to achieve now. Okay, so the API parses the entire database of the calves, and it also matches the data parameters which are already collected from the calf with the already existing data in the databases of DOT. Okay, so that we can ensure, okay, this data which is coming to us is very authentic data, and also can be used for the future reference. So that's the first step in the overall approach. And the second step is creating a mobile application, giving to the end retailers where the customer will be, where they will be interacting with the customer. So suppose, let's go to the same case what we were discussing, like in the rural village, one of the villages, customer walks in and the retailer takes the picture once the person requests the new SIM card, and that picture comes to the API, and centralized picture database again checks against this picture is checked again as the centralized repository using our machine learning model, which is already pre-trained. Okay, so that picks up the pictures which are matching. Then the matching images along with the registered numbers which are saved in the database will be displayed on the mobile, so that the user as well as the retailer will be prompted with how many SIM cards are already registered with that user. So with that, if the retailer will be alert if the number of SIMs are exceeding 9, and the user also will be prompted that whether he is the real user of the real owner of those registered numbers or not. So if there is any conflict is there, then immediately they can go to TAFCOP application, which is already in place, and deregister them from the existing portal, so that both the parties will be on the safe side. So that's what we are trying to achieve in the overall thing. So for the face recognition, we are using single sample face recognition approach, where we are, because the calf image is only simple image what we are getting now. We are not getting the multiple images of the same customer. So this approach we found very suitable approach. Moreover, but there are a couple of challenges are there in that, having different poses, expressions, and illuminations, and etc. These are the parameters we considered. So we are using hybrid method, which includes both local and holistic features of the face landmarks, and also we are using, as I told you, deep face algorithm, so that it gives the for example, if I take one picture of that, and we can actually create different angles of the same picture as shown in the slide, and the entire model is trained on these set of images, so that any angle in any other store, if the customer is taking the new SIM card, will be once taken the picture, it will be searched against this entire database. So with that, we can improve the efficiency of the overall model, and with the limited database what we've been provided with, we could achieve close to 85% of the accuracy, the model with 10,000 images. And given the more sample of the data, we are very sure that the more accuracy can be increased more than 90 to 95%. Then just imagine where all the retailers are connected to the simple repository of these all the images, and the moment the customer comes for a new SIM, this images goes to the model, and model checks the validates against the existing one, and then tells that okay, these are the different SIM cards. So that solves a lot of problems around us. Okay, that's it for the that's it about the use case. Okay, and I have one more request to the department, is that if in future, if we have any repository of the use cases around the repository of the problem statements, not use cases, problem statements that the department come across in a public domain, so that different stakeholders like academia and startups and also SMEs can pick up one or two problem statements, and if they can commercialize it, it's wonderful. Otherwise, if they can come up with the good solutions around it, okay, that is actually useful for the entire society. That's what I have a small submission to the department. Thank you.
Thank you, Mr. Srinath. That was an awesome presentation. And with this, now we have come to the conclusion of the technical session. So the next session is question and answer session. So which our guest speakers will take the calls. And now I hand over the platform to Siddharth Kumar to take over the question and answer session, followed by vote of thanks. So over to you, Siddharth.
Thank you, sir. Thank you, sir. Dear participants, the floor is now open for your questions and discussions with our presenters. Anyone having question may raise their hand. They will be given the right to speak, and then they can ask the question. Dear participants, you may ask the question by raising your hand. We are four of the presenter with us, apart from Meena Arunachalam ma'am, who has already taken the question answer session.
Well, I have a question for Saurabh Basu.
Yes, sir.
Saurabh, you have said that the CAP application has been,
Hello, sir. You are not audible, sir. Can you repeat once again? Hello. Sir, your voice is not audible.
Srinivas, sir, your voice is not audible. Meanwhile, we may take questions from chat. I can get that. One is for Srinath, for Srinath Reddy, sir. Is your face recognition system? Hello.
I'm not able to hear you. Hello.
Mr. Srinath Reddy, there is a question for you. Is your face recognition system could differentiate a shaped face and a non-shaped face?
Yeah, when it comes to the shaped, non-shaped means at what level the beard is there, first thing. And yes, as we are using the multi-dimensional face recognition, in most of the cases, actually it is detecting. Okay. The major challenge is the shade and the light. I mean, how far it is clear. These are the things which we are actually working on. So to answer this question, yes, it is actually working properly.
Anyone else who wants to?
And there was one more question again regarding that. For your model, success rate is 85%. What of the remaining 15% which are wrongly detected? Yeah, as I explained in this point also, that as the database side which we have given, which we provide is only 10,000 images, which is very less compared to for a country like ours. So if the data is more, okay, and you know any model can be trained once you have good data, and also it gives you good results when you have good data. So we are very sure and we are very positive. given the more data, we will approach towards 100%. The second question for me, and in the chat, I think, do you see any other questions for me?
Yeah. Thank you, Mr. Srinath. I think these two were the questions directed to you. Anyone else? So I find any raised hands now. So I think we have come to the end of today's webinar session. So on behalf of NTIPRIT, I would like to thank our guest speakers for engaging us in insightful and informative session on application of AI in telecom domain. Thank you, sirs, and thank you, Meena ma'am, in for sparing your time for this webinar. I would also like to thank Secretary Telecom, sir, Shri K. Rajaraman, sir, for his gracious presence and inaugural address to this webinar. I would like to thank Member Service, sir, Shri A.K. Mittal, sir, Member Technology, Shri A.K. Tiwari, sir, and DG Telecom, Shri Nijamul Haq, sir, for presence. A special thanks to DG and Head of NTIPRIT, Shri U.K. Srivastav, sir, for his guidance and support in organizing this webinar. Last and not the least, thanks to all the participants from industry, academia, field units of DOT, TEC, TRI, everyone who registered in today's session. Your continuous presence and engagement in all the events organized by NTIPRIT keeps us motivated to bring out more and better such events. Thank you, sirs and dear participants. Sir, now with permission of DG, sir, we may close the session. Sir.
Yes. Thank you very much. Thanks, everyone.
Thank you, everyone.
Thank you, sir.
Thank you for the opportunity. Goodbye.
Thank you.
Bye.
Thank you, sir.